All right, so this one says, De Anza students, ooh, good for them. Height for Asian adult males is normally distributed with an average of 66. What was this one? This was, I lost track of it. Blah, 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 blah. There it is. Batman. So the average is 66. And a standard deviation of 2.5. And we know it's normal. In a probability question, why is this important to know? Why is it good that it's normal? They're going to ask me probability questions. I know it's been a while since we talked about this. But what is that thing you got from me last time, if you were here last Monday? I wasn't here Wednesday myself. Yes?
The chart.
The chart. What is... Yeah, it only works for normal. It's got a bunch of answers on it. Somebody made this chart. It's got all the answers on it. We just have to know how to read it and when it's okay to use it. So if I know it's normal, I'm allowed to use a chart. Why is that nice? All the answers are sitting there waiting for me. Right? That kicks so much ass. So a big part of statistics then, which makes sense, is in different situations, how do I know I have something normal enough to use that chart? Because then I know all the frickin' answers. If it ain't normal, that would be Stats 2, which we don't teach here. Maybe someday. I'm going to put a proposal in for Stats 2 class, and you're all like, dude, slow down, shit. Let's focus on Stats 1. All right, so the question is, I keep forgetting which one it was. There it is. I'm doing the right one, right? I always hate when I get like halfway through a problem. Who asked that question?
Yeah.
Yes, okay, thank God. Blah, blah, blah. On part D?
Yeah.
Oh, good. All right, this is a question we're going to ask today. By the way, real quick, I know this book is a little weird. They ask you X is distributed how, and N for normal, B for binomial. You should be kind of used to this by now if you're doing the homework. This is a little unique to this book. And what you put in here is the two most important things, which of course is the mean and the standard deviation. For a binomial, it would be N and P. For a uniform, it would be A, B. Right? So they kind of like to put the most important things about it compactly. Right? If compactly is a word. And then part D says the middle, middle 40% of heights fall between what two heights? I don't know if anybody's done this problem yet. Somebody did, and they skipped part D, so apparently that's a problem. But can you draw that for me? What would it look like? We know this, but now put on there this. Middle 40%. Nobody's drawing. I know not everybody's done this problem. Can you draw me the middle 40% on a normal curve? Draw it real quick. I love you guys. Some of you guys are like, you want me to do shit? All right. So I know it's normal. Middle 40% would be just chop in the middle. And how much is in here? Well, 40%. They want me to find the heights here and here. Okay. I'm always so hopeful for what I'm about to write down will actually help people. Well, a normal z-score problem, and I know it's been a while since we did them, but do you remember doing the one about the parking time? It takes so much time for a student to find a parking spot. So what's a normal z-score problem? I give you a raw score, like what's probably it takes somebody 38 minutes or more to find a parking. Okay, 38 would be the X. What do I have to do before I can look up the probability? I'm going to change that into a z-score, so I can use the z-score chart. And then I can look up the area. I can look up the probability. Is everybody with me? So I give you a raw score. It could be length of a dog's tail. It could be the lifespan of a snail. It could be, I don't know why I'm rhyming. It's Dr. Seuss stats. I won't calculate it in a box. This problem starts with the percentage. So then, and it asks me for a freaking raw score, a height. So what do? I look up the z-score, and then I calculate it back into an x-score. And we know this formula for damn sure. That's good for going that way. What's the formula look like for going the other way? If I know z and I want x. This is good if I know x and I want z. What's the formula look like if I know z and I want x? Something. I don't know. Anybody? I love you guys. Anybody remember that? Or you could just do it again real quick. Do a little algebra, solve for x, right? How do you solve for x? Are you guys all right? What happened this weekend? You guys still wherever you went yesterday? X equals mu plus z sigma. Right? Does that look at all familiar? So that's another formula you have sitting on your formula chart. So why is algebra in existence? Oh, so many reasons. But what's one of the most primary reasons? To learn how to manipulate formulas. This is really good if I don't know the z and I know everything else. This is good if I don't know the x, but I know everything else. They're the same formula, just reorganized. So in this case, I can look up these z-scores and then convert each one of them back into a height. How the shit do I get this z-score, for example? So this is maybe this is where I need to go back and remind you how to use this chart, because it's been a while. Anybody not, let me say this really slowly while I look for them. Ah, good. Not get the chart yet. The z-score chart. If you did, you would know what I'm talking about. All right. Back that way, and Gracie back that way, and back that way. Ready? All right. Oh shit. So before we do this problem, especially because there's a ton of you that didn't get this before, let's remember how to use this thing. Focus. There you go, buddy. All right. Let's kind of put this problem on hold for a second. And let's just focus on the chart. Okay. So remember last time, so that you understood and bought into the chart, I started with the empirical rule, which we know is true. So, for example, if I have a normal curve, what percent should be within one standard deviation of the mean? What's that first number in the empirical rule? Within one standard deviation of the mean. 68. Within 2 is 95. So there should be 68% in there. So any chart that claims to get areas for normal curves better frickin' agree with that. So if there's 68% in there, how much is outside? There's 68% inside, how much is outside? 32%. So how much is on one side? 16, 11. Very simple manipulation of it's all one, so that when you parts and it's symmetric, right? So how do you read this chart? Anytime you look up a z-score in this chart, it tells you the area below what you just looked up. So if I look up negative 1.00, it better be about 16%, or we can all throw this thing away and do other things during this time. So if I look up negative 1.00, I do get, if you round that, 16%. So to make the empirical rule easier to remember, we just rounded all the stuff off. You guys with me? Empirical rule sucks, though, because the z-score for something doesn't have to be negative 1, negative 2, negative 3, for it could be negative 2.87. The empirical rule sucks, but then I got the z-score chart. So if I wanted to know the area below negative 287 z-score for a normal curve, take a minute and see if you can look that up. Negative 2.87. That top row is the second decimal place. Negative 2.87. It's always freaky looking over there. There it is. You guys get that? You guys see that? So anytime you look up a z-score in this chart, the answer you get, you should immediately put on your picture below what you just looked up. And why does this make sense? Why does it make sense that it starts off so small and it slowly grows? Because if you look at it, so what this chart does is it tells you the area below the z-score. So as I move up, as my z-scores get closer to 0, I got more shit below it. Is it growing very quickly down here? Is it growing? Some of these don't grow at all because they grow in a place further down than the fourth decimal place. Why are they growing so slowly? Because it's really tiny out here. When am I going to start growing quicker? The closer I get to the mean. So down here, do you see how they're all growing really quickly? Now it's going up by 3%, 4%. Because it's taller. There's more stuff in there. Okay, maybe. I love you guys so much. And I don't want to hear anybody say, well, I can just push a button on the calculator, it tells me. I don't give a shit. I'm hoping subconsciously, I just now try to make it very conscious, but subconsciously you should get a better feel for the layout of a normal curve using this instead of buttons. I know, I'm an old-fashioned kind of guy. All right. So coming back to this dude. If I can look up a z-score and get an area, I should be able to look up an area and get the z-score. Math works both ways. Right? There's inverse functions that exist for most things, a lot of things. But what's the problem with that number 40%? What area does the chart understand? What's the only area it talks about? The area that is below a z-score. So if I look up 0.4, I'm going to get the z-score that has 0.4 below it. Oh my God, this is beautiful. I'm not going to get the right thing, right? You can't just hope the chart understands what you mean. It's not like Google. You start mistyping something and it goes, did you mean this? Oh yeah, thanks Google. No, this shit you got to go in and know what the hell you're talking about. That's part of what my theory about Google effect and how it's affected education. But anyway. So what the shit, how do I find the z-score? If I look in the chart, I need to know the area below that z-score. Why do I want this z-score? Because I want both of these stupid things. So I can figure out what those heights are. So I want to be able to say, a dude, or in this case, I can't remember what this was for Asian males. Yeah. Asian dude, there's 40% between this and this height. That's what I want to end up being able to say. So to find the z-score, I need to know the area below it. What's the area below that z-score? Oh shit. Should be capturing this. What is the area? Say hi, everybody. Hey, Jeff, I didn't sign a waiver. I don't want to be in there. Sorry. All right.
As long as you don't monetize the videos.
No, I never do that shit. That's the worst. If it takes longer than, like, if I can't skip the ad, screw it. It wasn't interesting enough to watch anyway. What is the area down here? Like we just did a minute ago with the 68%. What's the area down here? 40% inside, so that means there's 60 outside, which means there's 30% on that side. If that's difficult, I don't know what to do for you, really. It's not difficult. So that's 0.3. Look up the z-score. Try to see if you can't find as close as you can to 0.3000. So we're doing this backwards now. We're starting in the body and trying to see what the z-score would have been for 0.3. And you know it's negative, right? Because it's down here. What's the closest you can get to 0.3000? Must be down here, right? Say again?
Negative 0.52.
So you're saying the closest you get is 0.3015. Sounds good. Because the next candidate would be this guy, but that's 19 away, and that's only 15 away. Now listen, some of you guys, if you split the difference, it's fine. If you had no idea what I mean, then just don't. Get the closest. So that's negative 0.52. Stay with me now, come on. I really, think about it like this. The mean has what percentage below it? The mean has what percentage below it? 50%. I want 30% below it. So doesn't it make sense that I should go down from the mean a little bit? How far down from the mean? Negative 0.52 standard deviations. If I go about half a step down from the mean, I end up with about 30% in the tail. I love you guys. So that z-score is negative 0.52. Anybody have a guess for what this is going to be? Think about symmetry. Positive 0.52. That is too beautiful, right? Just to verify that, what area is below it totally? What's the total area below this guy? 0.7. So the closest I can get to 0.7000 looks to be up here. 0.52. So the symmetry in a normal curve makes a lot of your work quicker. But if you forgot about that shit, you just look it up like we did the first one.
Is this top row or like the top part right here? For
That's the second
column?
decimal place.
Oh, okay.
So if I want 0.17, I go 0.17. So that would be the area below 0.17. If that's what I wanted. Sorry.
Oh, okay.
So if I look at 0.52, that's the one that's got 70% below it, or close enough. So that's why that's 0.52. Now what did this question want from me? It wanted the heights. How do I convert these back to heights? Use that formula. We know this, we know this, and now we know these two things. In fact, I'm going to try to push it, although I feel like I probably shouldn't, but couldn't I write, for the middle anything, it would be mu plus or minus something times the standard deviation, right? The middle 80%, middle 90%. It's always going to be plus z minus that same z, because of symmetry. That's going to become huge in chapter 7, that idea of the middle something, going up and down to capture the middle something. Oh, shit. All right, does that help out? Who asked that question? That has to, because I basically am one step away from the answer, so. Anything else from homework stuff before we get I'm going to do a few more review problems, I think. Okay. So let's just do a couple of things. Let me make sure everybody in this room, does everybody have a z-score chart? If you forgot yours, let me know. You could borrow one. Everybody's got a z-score chart. All right. So take a minute and figure this out. For a normal curve, actually standard normal curve, which means it's just all z-scores. Take a minute and see if you can figure out what this is. Try to draw it. Some of you guys will never draw it, and you'll make stupid mistakes. This one's not that bad, though, but still try to draw it and then try to look it up. Let's see who came in. Christian. Escobar. Michael. Jared. Austin. And TC. Chris Smith. Okay. All right, so if I draw this dude, they told me it's normal, standard normal. What goes right in the middle? 0. So for standard normal, what that means is all the values have been made into z-scores. If the z-score is the distance from the mean will always become 0. Only makes sense. 1.17 then better be over there somewhere, or else it's a very fundamental problem. And then shade in the area that I want. Make yourself a visual cue for what the answer should be. So I want this area. So I already know it should be more than 50%. So what do you guys get when you look up 1.17? Say again? 0.79? 8790? So if I look at 1.178790, I love it. Does everybody see how to use that chart? Okay, I like it. So there's two sides to any math course, really. There's the technical, do you know how to do shit? And then, especially in statistics, there's the, what the hell does that shit you just did mean? Right? There's those two sides. And we talked before about how tall they made that door, how many tickets to oversell for a flight, how wide to make a plane seat so you have less complaints, so forth. How do you figure any of that stuff out? Using this. So if I only wanted 2% of all men to have to duck going through a door, I would make the door the height that has just 2% above it. If I know the average male height and I know the standard deviation male height, I can figure out what that is. You guys semi with me? So the power of what we're learning right now is insane. It really is. And there's more things that are normally distributed than you realize. Not everything. Oh shit. So to convert this back, oh no, that was another problem. That's done. So 0.8790. Please, dear God, circle your answer or make it really clear what the answer is. What if I had this question? Z greater than 0.92. So draw that situation, look it up, and then we'll talk about if you got the right answer. Huh? Tricky, okay. Don't mean to be. I really, really don't. Okay, so in that 0 in the middle, positive 0.92, so it's going to be up here somewhere. But where's the area I want now? It's greater than. So you really got to get used to, when you look up a z-score, immediately put what you find up top in the picture below what you just looked up, because that's what the chart means. Some of you guys might remember I talked about a shortcut. I'm not really going to bring that up much anymore. If you like it, you can use it. 0.92, what did you guys get for 0.92 when you looked up 0.92? 8212. Now, it does not make any sense that this is 0.8212 because it is less than half the frickin' picture. So don't just plot that thing in there. That's kind of like assuming the chart's smarter than me, so it's going to know. No, what the hell? You're smarter than the frickin' chart. It's a piece of paper, right? So what does it always tell me? Area below. So how do I get what I need? Was that what it was?
1 minus.
Yeah, 1 minus that. Some of you guys remember. You might remember that the shortcut was involving looking up the opposite sign z-score, getting the answer, because of symmetry. If you don't understand that, never use it. Sort of like the blinkers on your car. So what is 1 minus this? That sounds like a history quiz or something. So what does that mean? What does that mean? Almost 18% of all z-scores are above 0.92. That's what that means. Does this have real physical meaning yet? No, because they don't know what these were measuring. They're just z-scores. They could have been, again, lifespan of snails or length of dog tails. It could have been anything. I don't know what the physical meaning was behind this. I really want you to understand. In fact, real quick, if this was all about men's heights, wouldn't this be inches minus inches divided by inches? Don't all the frickin' inches cancel?
Yes.
So there are no units on a z-score. You can argue that it's like standard deviations, but it's, if anybody knows radians, it's kind of the same idea. If you don't worry. Okay, all right. So let's try one more problem out, and then I'm going to ask you to get together with somebody else and work on this little worksheet. So let's do one that I give you some more information. Let's say on a test, the mean was 74.8, standard deviation of 20.123, which is basically what the last quiz was for us. And I know it's approximately normal. I'll say normal enough. If I say that, that means normal enough to use the z-score chart. So find the probability that somebody scored between, what you got, Jeff? 80 and 90. Try to do that. Try to draw the picture. There's going to be a couple of z-scores to calculate. Try to get as far as you can. I think it's going to be about 17%. Let's see. So you have two z-scores to create for this problem. This might be a little weird if you weren't here last time and you're trying to catch up with how all this shit works, but this is a normal curve. It's a probability question. I know I have to make z-scores. So how do I make 80 into a z-score? Yeah, but x, the one I'm interested in, 80, minus the mean, I like it,
Over 20.12.
divided by how big its step is. It's like 0.25, but it's going to be maybe, well, I don't know.
How'd you get the denominator? Oh, okay, I see behind you.
Yeah.
Yeah,
Yeah. So if I didn't give you this, you couldn't do the problem. I love that kind of quote. What if you don't give me that? Well, then you can't do this. I don't know. We need that. What do you guys get for that z-score? .26? Is that what you guys are getting? Like 0.25 something like that? Gotcha. So 0.26. Why do I round it to two places?
That's what the chart is.
Because that's what the chart needs, Jeff. All right, I like it. Good. I do have to say something about 5 times until everybody understands it. But I appreciate that. And then making 90 into a z-score, same idea. Do you see how the z-score does tell me how far above the mean or below that I've gotten? And like we said earlier, that should directly relate to how much area is below that. So what's the z-score come out to be? 0.76. Doesn't make sense. I like it. So this was 0 for the mean. This one became 0.26 and 0.76. So if you are a student that likes to be nice to yourself, I highly recommend you put those on the picture. So what do you get when we look up 0.26? What do you get in the chart? Aw, poor little dude. 0.26 in the chart, what do you get?
0.6026.
6026. So I immediately put it below the thing I just looked up. And when we look up 0.76, 7764. I like it. So you immediately put it below what you just looked up. I love it. The people that don't draw the picture are going to make the silly mistakes. So am I going to take points off just because you didn't draw the picture? No. But it's a very high probability I'm going to take points off because you get the wrong answer anyway. So now I just subtract those. Remember I predicted 17%? So the answer comes out to be 0.1738. Yes? Cool. I like it. I like it. So roughly 17% of students would have made a B of some kind. I like it. All right, so do find somebody near you to at least sit next to as you do this worksheet. Anybody need to borrow a calculator? Come on up and do that. Yeah. Make sure this. Oh shit. See if that has battery. Make sure it's got battery.
Yeah.
Sweet. Make sure it's got battery.
Thank you.
Oh, got the old school ones.
So, and you found whiskey.
All right, let me give you these. Thank you.
So you subtract this one from that.
If you need to, you can even turn around and work with people behind you.